So here we're going to look at a power to a power property. How do I raise a power to a power? And so with that being said, again, I like to write it out. I'm big on writing these out. So what does it mean when you have n to the fourth power to the third power? Well, it means that we're going to have 3 groups of n to the fourth. And then if we write out n to the fourth times n to the fourth times n to the fourth, we know that we're going to have 4 here, and 4 more for the middle, and 4 more for the end. And so what do we have total? We have n to the 12th. Oops, sorry about that. Wrote that wrong. N to the 12th power. So let's talk about the rule. What is the rule with power to a power? Well, if we have a value raised to a higher power, we're going to multiply those. So we're just going to multiply the 2 powers, the 4 and the 3, we multiply that, and that's how we get the 12. We have to be very careful to be able to identify if it's product, what we did yesterday when we add, or if it is power to a power where we are multiplying, because we'll get 2 different answers if we were to add those or multiply those. So again, if you're ever concerned on which one it is, write it out. What I want to remind you, I'm going to write out the next example. The next example would be 5x cubed times 5x cubed. If I were to write that out, it would be 5xxx and 5xxx. And so what do we get is 5 times 5, we get 25x to the 6th. So let's talk about this one and how it's a little different when you have that coefficient, that number 5 in front. I want you to remember that the way that that number 5 can be written out, or what power it has, is it actually has the power 1 next to it. So 5 to the first power, x to the third power. So if we were to use our rule and multiply, 1 times 2 is 5 squared. That's how we're getting the 25. And then if we multiply my 3 and 2, we get x to the 6th. So 5 squared is that 25x to the 6th. Again, you can always go back and write them out. Let's go ahead and look at one last example that probably looks a little bit more nerve-wracking here, because there's a lot. And we could write it out except for we've got that negative exponent. So let's actually use our rule here. I would look at this problem and I would give everything an exponent. So what is the exponent on the 6? Well, it's the exponent of 1. What's the exponent on the A? It's a 1. What's the exponent on a B? It's a 1. Let's look at the other parentheses. What's the exponent on the 5? It's a 1. And what's the exponent on the A? Well, it's already written, it's negative 3. So if we go ahead and look at this, and if we multiply, we have to multiply all those exponents by the power on the outside. So for this first parentheses, we're multiplying by 3. So I have 6 to the third, A to the third, B to the third. Let's go ahead and look at my second set of parentheses. I'm going to multiply everything by the 2, power to a power property. So 5 squared and A to the negative 6th. So now what we can do is a couple of things. I would suggest that we look at what we have. We have one of those letters written twice, a cubed and a to the negative 6. And so we can use our property we learned yesterday, the product multiplying. We can add those. A to the third and a to the negative 6 would be a to the negative third, 3 plus negative 6. Bring everything else straight down. We are simplifying. In order to be simplified, we have no negative exponents. We don't see any letters written more than one time. I have a negative exponent right here. It's got to go to the bottom. Picture this as a fraction over 1. So in the numerator here, we are going to have 6 times 6 times 6 times 5 times 5 times b cubed. That's all going to be in the numerator. And in the denominator, we're having a, and our power becomes a positive, a cubed. And so if we evaluate, that's a pretty big number, but if we evaluate, type that in, we get 5,400 B3 divided by a cubed. And that is simplest form. We have simplified, we have no negative exponents. We have no letter A's or letter B's written more than one time in our problem. And we're simplified. That's it.